Alright, let's do problem 4. This is the one about the cylinder. I'm going to do it not in this small space because I want to write large enough that you can see it in the video. So I will do it here. But the problem is about a cylinder which is getting shorter and getting wider over time so that the volume remains constant. We were calling this height L for length. This is radius. The volume is a constant of 1,000 cubic millimeters. Let's write the equation for volume. So volume is this cross-sectional area times the height, which is true of any shape like this. So we've got h times pi r squared. Okay, it is safe for me to substitute in the 1,000 here. I'm going to write it this way, pi r squared h. Because I know that the volume is not changing, I can't substitute in a number for h, because the whole point is that h is changing. And if I put a number in there, now this equation says h is always that number. So if I took the derivative, that would be totally wrong. Again, the volume isn't changing, so it's safe to put the number in there. And when I take the derivative, that becomes 0, which is what it should be, because the rate of change of volume is 0, because it's not changing. All right, so I want to find the rate of change of radius. So let's take the derivative of this equation to find rate of change of radius. Derivative of 1,000 is 0. Here I've got pi times the derivative of r squared h. So immediately I'm saying we got to have product rule. So let's do the product rule. We have 2r r prime h plus r squared h prime. I'm trying to solve for this term here, r prime. So I don't actually think, you could plug things in at this point. This is going to be simple enough that I want to solve for r prime first before I plug anything in. So I'll start by dividing both sides of the equation by pi. So now pi is gone. I'm going to subtract this term. So now I have negative r squared h prime equals 2r h r prime. Now let's divide by everything that is not r prime. So I've got r prime equals negative r squared h prime over 2rh. I notice this r cancels with one of the r's here. So I have r prime equals negative r h prime over 2h. Okay, let's plug some things in. So I know from the problem that h is supposed to be 250 millimeters. It says that that h is decreasing at a rate of 8 millimeters per hour. So if it's decreasing, the rate of change should be negative 8 millimeters per hour. What's r? We have to figure out what r is. Let's do it over here. So I know that the volume of 1,000 equals pi r squared h. So that means r squared must be 1,000 over pi times h, which is 250. So that means r must be the square root of that at the particular time I'm talking about. So now we've solved for r, so I can plug that back in there. So that gives me that r prime should be what? Negative square root of 1,000 over 250 pi times negative 0.8. So the negatives cancel, so that's positive. And now in the denominator, 2 times 250. So that means r prime is 0.8 square root of that stuff over 500. And if you plug that into a calculator, what does it come out to be? I think I did this already. Yeah, all right, so it should come out to be 0.0018 millimeters per hour as your rate of change of radius with respect to time. So again, I think like if you know what you're doing, and if you've done a lot of these, it all comes out pretty quickly. So I think what we need to do as a class is practice more of these until we can really push them out in like 3-4 minutes apiece.